Yes, this is what we have seen in the last class. That is, we were introduced the manipulator kinematics. In order to know the basics, we need to start from the simple kinematic structure, and this is what the two manipulator which we were introduced in the last class. One is RR joint, the other one is LL. Um, the RR joint, which has the rotary motion, rotational motion, and LL, it has only linear motion, and this were the structures we were introduced. There are two different types of coordinate system we follow in this kinematics. One is there are two different space. One is joint space, the other one is world space. This is what the we need once we are trying to move the end effector as per our wish. We should have the control over the end effector, and for that we need to have whether the position is at what was the position, what is the position we need to keep, and that is the whole which we should usually have a conscious. For that, we need to start the numbering from the base. Concerning this particular case, we need to start the numbering from this one. We already aware that we have joints and links. Joint 1, joint 2, and joint 3. Joint 3, we have the end effector. And the end effector coordinate system we usually called as x and y, and we are worrying about the position of that x and y from the origin. This is what we are going to do. Representation of the joint spaces Pj, and the world spaces Pw. In the case of Pj, we are going to notate with the aid of the inclination, and the world space that we are going to introduce with the Cartesian coordinate. When the three dimension comes into picture, we need to include the third ordinate, and the converting the joint space into world space, usually called as forward transformation or forward kinematics, and converting the things from world space to joint space is called reverse transformation or inverse kinematics. And this is what we have introduced in the last class, that is forward transformation of 2 degrees of freedom arm. And the position, we were introduced with L1 cos theta 1, L1 cos sin theta 1, and similarly we have R2, and by accumulating the above two equations we will get the x and y, and this is what we achieved in the last class. And we usually term the theta in the positive inclination, and when it comes into negative inclination, and this is the thing when we actuate the end effector during the negative direction. And in order to get the unknown, that is cos theta, theta 1, theta 2, and all, we did a simple calculation. I requested someone, I think this is Chitas, I think did, and we have x and y. We have abbreviated the cos a plus b, and we have this equation. Yes, 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 yes. Kishore, which one is not understanding?
No, sir, we are not able to see your screen.
Screen, oh, sorry, I didn't share. Yes, yes, yes. Yes, now it is visible. Yes, yes, yes. I request some people to join with us for today's conversation. Please unmute your mic and please join with us. Till then, please join with us. Yes, from 95, 96, 97, 98, 99, 100, 102, 103, 104, and 106. Please unmute your mic. Please join with us. 91,
Yes,
that is 95. Yes, yes. Yes, similarly, other two also, you please respond. Sai Ganesh, Samar Prasad, Sabarni, Yoga Anand, Samrut Rahul, Govind Rajan, Shanu Kumar. Jaishwal, Harini. Yes, till Sri Harini, please unmute your mic and please join us. And Johanna.
Yes, sir.
Johanna. Yes, there are many things to discuss. We have the NASA released the recent videos about the that new launch, and we were failed in such a launch. We at the end the India failed, and we need to learn a lot. Once time permits, we'll talk about it, and there are some other issues also to discuss about the Pondicherry government fails, and similarly we have some other the BRICS summits. I think China will be the key will disseminate some key issues, and similarly we have some major issues. Once time permit, will reveal such points. Once the today's content is over, when we have time, at that time we'll disseminate. Tatacharya, is Tatacharya. You want to share anything, Tatacharya?
By mistake it happens.
Okay, no issues, no issues. Yes. Anyone collected the information related to NASA? The recent video. See, this is the site, official site. And anyone seen? Anyone has this, content to disseminate?
No, sir.
If it is,
Yes.
yes, someone.
So they have for
So
pass
they
of so
for
they have
pass of
what
so they have
Just a minute. I will come back to you. Yes, sorry for the interruption. My mentor made a call, and okay. Someone talked about the NASA. I know.
yes, sir.
Yes.
Yes, sir.
Yes. Tell me.
Sir, the Perseverance rover of output landed on just
Yes, of course, Justuna, you please collect some content related to the technical specification and all, and where we failed like that, you have a study, and during tomorrow's class, you go ahead with that content, Justuna.
Yes, sir, sure.
Yes, sure. Okay, good, good. Okay, we'll start the content, and this is what, yes, this is what I have shown, and unfortunate that I didn't share the screens, and this is what we have already discussed, and the joint space, world space, conversion of joint space into world space, from world space into joint space, the forward kinematics and inverse kinematics, and R1, R2, and X and Y, and we were converted the x and y, and we derived theta 2 and cos theta 2, and your Chitash did the derivation, that squaring on both side, and I will go a little slower and see the derivation, and a square plus b square plus c square plus 2ab minus 2bc minus 2ce. This is what he did. L square cos square theta 1 plus L2 square cos square theta 1. Please make a note. Please make a note. Please have your notebook, and please take your calculator to, please take your, please make a note of this derivation and all, and you please make each and everything which we are disseminating, and plus L2 square sin square theta 1 sin square theta 2 plus 2 L1 L2 cos square theta 1 theta 2 minus, and 2 L1 L2 and so on, minus 2 L square and so on. And similarly he did y square also, and then later he added x square plus y square. While adding the x and y, we'll get x sin square theta plus cos square, that becomes 1, and by getting the powers, power 2 in one side, we'll get x square plus y square minus L1 square minus L2 square is equal to L1 L2 cos theta 2. Therefore cos theta 2 becomes x square plus y square minus L1 square minus L2 square by 2 L1 L2. This is what we will get for theta 2. And for why these derivations and all necessary, now to push make the end effector as per our wish, now to do the changes over the end effector, we need these data. The theta 2 at the second joint, and therefore we need to do changes with, we have theta 1 is here, and when we are aware about theta 2, then only we can make a movement over the end effector. Therefore we derived how we can get the theta 2 with the aid of various other basic informations, that is based on x and y, and based on the link to the x and y is the Cartesian coordinate of end effector, and L1 and L2 might be the length of the joint 1 and joint 2. From that we can get the theta 2. Yes, see here, and we were introduced some other typical symbols, and this is theta 1, and inclination, this inclination might be alpha, and the addition of theta 1 and alpha is beta. The inclination with the joint 1 axis, sorry, link 1 axis with the link 2 might be theta 2, and this is what I have requested someone to do, and I have given his photograph, his derivation. Here tan alpha is equal to L2, that is what we need to do. What he did, he made a triangle, and this is what A and B and C. It might be the right angle triangle, and here BD is L2, and our AD is L1, our BC is equal to, in this triangle, from this BDC triangle, sin theta 2 is equal to opposite, sin theta 2 is equal to opposite by hypotenuse opposite is equal to our BC and our hypotenuse is equal to L2. Therefore, we will get BC is equal to L2 sin theta 2. Similarly, CD is equal to L2 cos theta 2. Similarly, we are going to derive with the larger triangle, that is ABC. Here, instead he introduced the inclination C, A, B, which has the A has inclination alpha, and therefore tan alpha is equal to BC by AC. We have he already derived the values of BC, AD and CD. Therefore, instead BC he introduced L2 sin theta 2. By AD we have AD, L2 cos theta, L2 see AD is AD is L1 and our CD is cos theta 2. This is what the derivation of tan alpha. Shall I move further? Do you have any doubts? Do you have any doubts? Shall I move further?
Yes, sir.
Yes, sir, you
Yes,
can
sir.
move further. Yes, sir, you can
Yes,
move further.
yes. Tan beta is equal to y by x. In this triangle, tan beta is equal to, in the larger triangle, assume there is a larger triangle with this x and y, and therefore tan beta is equal to opposite by adjacent y divided by x. Here we were already taught about the addition of theta 1 and alpha. Theta 1 and the alpha is equal to beta. From that, beta minus alpha becomes theta 1. Therefore, we need to get tan theta 1. We will derive the tan theta 1. See here, now we are concerned about theta 1. Here what we concern, here we concern about theta 2. Now we will concern about theta 1. What might be the theta 1? We will derive. This is what the theta 1. Tan theta 1 is equal to, we have y L1 plus L2 cos theta 1 minus x L2 sin theta 2 divided by x L1 plus L2 cos theta 2 by plus y L2 sin theta 2. Already we have tan alpha, that is L2 sin theta 2 divided by L2 cos theta 2 plus L1. We have tan beta, and we know the relation between beta and alpha. What I am going to do, I am going to take tan on both sides. I'll get tan theta 1 is equal to tan beta minus alpha. See here, tan theta 1 is equal to tan beta minus alpha. I am abbreviating this formula, that is tan A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. Therefore, I'll get tan beta minus tan alpha divided by 1 plus tan alpha tan beta. We have tan beta is y by x, and similarly we have tan alpha, we have certain terms, and I am introducing those terms instead of tan beta and tan alpha. And here what I am going to not make the common denominator, and I am multiplying the x with this denominator, and I am doing the cross multiplication, y into this term minus L2 into sin theta 2 into x. And similarly, I am doing this simple calculation at the denominator portion. Here the entered denominator, and here also we have x into L2 cos theta 2 plus theta 1, and this I am going to multiply with 1. I'll get the same result, plus y into L2 sin theta 2. What I am ultimately I am getting the common denominator. By cancelling the denominators, I'll get y L1 see L1 L2 cos theta 2. I am rearranging. I am making L1 first, and here x L2 sin theta 2 divided by here x into L1 plus L2 cos theta 2 plus y into L2 sin theta 2. Is this what? Tan theta 1. Therefore, we got theta 1 as well as theta 2. And we have various L1, L2, x1, x2, and x and y. Therefore, we are well aware with the 2 degrees of freedom. The entire, we have one space parameters. then we can transfer from one space into the other space. In particular, or in instance, take it as the data were given into joint space. We can convert those data into world space by having these formulas. Do you have any doubts with this derivation? Shall I move further?
Yes, sir. Yes, sir.
Yes. Okay. Okay. I am adding one more degrees of freedom with the past. I am adding one more degrees of freedom with the past. That is, already we are having 2 degrees of freedom. Here I am adding one more joint and link. At the end I am adding one more, and the inclination with the link to x is theta 2 here, and from the base, from the x, the inclination is psi. Here we have x1 y1, x2 y2, here x3 y3, and at the end effector we have, see, at the end effector we have x and y. Okay. Till this portion, we can take the past results. We can find the unknown with the aid of the past derivation, that is theta 1 or theta 2. From the past derivation we can find. Now what we need to aware about this theta 3 and psi. The past derivation results may be or might be used for getting these results without any hesitation, without any doubt. It can give the proper results for this degrees of freedom. And see, R1, R2 and R3, L1 cos theta 1, L2 sin theta 1. Similarly, we have R2, R3. What we need to do, we need to add the inclination at the respective place, and by doing so, we will get the x and y. This is what the x and y. And in the similar way, where we did in this 2 degrees of freedom, we derived the x and y and various other unknowns in the 2 degrees of freedom configuration. And this is what the relation between the introduced new unknowns, that is theta 3 psi, theta 3 and psi, the x3 y3 and x and y, and this x3 y3 x y l3 and the psi. Here we have I am making a larger triangle, and see, this is what your x3 and y3, and this is what our x and y. I am making a triangle, larger triangle. This is my larger triangle, and this is my theta 3, and this is my psi. From the x-axis, this is my psi, and the hypotenuse of this particular triangle is L3, that is link 3. This is what we were introduced. And here x3, y3 at the end, we have the end effector x and y. The end effector portion should be termed as x and y. Here x and y should be the portion of the end effector. Therefore, the horizontal distance we can get from the subtraction of x, and here we have x, here we have x3. Therefore, we will get by doing subtracting the x and x with the x3, we will get this horizontal dimension. Similarly, we will get the vertical dimension with subtracting the y and y3 will get. Now I am going to do the simple calculation, that is sin psi is equal to opposite by hypotenuse, that is y by y minus y3 divided by L3. From this, y minus y3 is equal to L3 into sin pi, and I am making this into other side, and y minus L3 sin pi is equal to y3. Therefore, y3 I'll get y is equal to L3 sin pi. Similarly, cos psi is equal to adjacent by hypotenuse, x minus x3 divided by L3. Here x minus x3 is equal to L3 into cos pi. X minus this term I am making this into LHS. My x minus L3 cos pi is equal to x3. X3 is equal to x minus L3 cos pi. This is what the new terminologies we need to make the addition over the last derivation in order to get the newly introduced terms like psi and theta 3. Yes. Yeah. Do you have any doubts with this system? Do you have any doubt?
No, sir.
No.
Yes. Yes. So, yes. In the single class talking, the derivations might be a little fatigue. Slowly we will enter into the problems. Once we are very familiar with, we are comfortable with these problems, we will see the derivation of this 4 degrees of freedom manipulator in 3 dimension. Anyway, you please make a note. In tomorrow's class, we'll try to derive this system. You now at present, you please make a note of this particular system. Yeah, 4 degrees of freedom manipulator in 3 dimensions. Here we have joint 1, and here joint 2, and joint 3, and joint 4. See, the manipulator has 4 degrees of freedom. At joint 1, it is type T joint, which allows the rotation about the Z axis. And concerning this joint, it is an R type. It allows the rotation about an axis that is perpendicular to Z axis. Perpendicular to Z axis, the rotation should be perpendicular to Z axis. And concerning joint 3, it is a linear joint which is capable of sliding over certain distance. And joint 4 is an R type, and which allows the rotation about an axis that is parallel to this joint 2. Thus we have T, R, L. The end effector has R. Therefore we have written as T, R, L, again R. This apostrophe used to differentiate the position of the end effector. The end effector, we have R type. Therefore, not to differentiate the end effector with the other system, we were introduced as apostrophe or colon. And you please make a note of this X and Y. That is world coordinate system or world space. The X and Y is equal to, X is equal to cos theta into L cos pi plus L for cos psi. Y is equal to sin theta, L cos pi plus L for cos psi.
So I will show the diagram, sir.
Yes. Once it is over, please tell me. Shall I move further? Shall I move, dear gentlemen?
Yes, sir.
Yes.
To the down formulas.
Yes, you make a note of these formulas. X and Y. and then we need to have a conscious about L, phi, and theta. Yes. Make a note of Z. Z is equal to Z4 is equal to Z minus L4 sin psi. And in reverse transformation, we have x4, y4, and z4. Here, you can you make it as this symbol instead this. Yes. Yes. Then you are L, pi, and theta. L, pi, and theta. The relation between L, pi, and theta. This is theta. This is not pi. This is theta. Yes. Okay, who is ready to take these derivations? Anyone willing to do these derivations? In the past derivation, Chitas and some other fellow did. And Chitas, what was the name of his? What was the name of someone did derivations?
Sir,
You and
Arun Balaji.
Arun Balaji. Okay, Arun Balaji. Okay, very good, very good. And who is ready to take care of the 4 degrees of freedom manipulator? That is, these are the things you have to do. With this basic system, you need to derive this. Anyone? Please. Anyone? Varshita, you do, Varshita. Varshita? Varshita, you are attending? I think she's sleeping. Rahul? Yes, Rahul. Rahul? Okay, Sabarni, you carry out the derivations, Sabarni.
Yes, sir.
And yes, so this once Sabarni given the content, tomorrow we'll include that with this page.
Sir, can you scroll up? I'll take
Yes.
that. I mean, I'll draw that diagram.
Diagram.
And also, sir, it's
You take a print screen.
Yes, sir. I did.
And this is, you take a print screen and work with that.
Yes, sir.
Okay.
Sir.
Okay, we'll start the conversion, that is homogeneous transformation. There are in the textbook, that is Groover presented in a nice way. There he followed 2 different approaches now to get a orientation. that is, he divided the sum with orientation problem and positioning problem. By separating this, we can find the appropriate position or the place of the end effector. One particular system is the homogeneous transformation and robot kinematics. And with these basic matrix multiplication, matrix additions, and subtraction, and basic matrix calculation, accordingly we can find the position of the end effector. And see, the point vector will one by one will talk, and the point, you please make a note. Already I have given these contents in the last class itself. Let V might be the point effector. Let V is equal to AI plus Bj plus Ck, and which is used to represent the three-dimensional space system. And we can make it into a column, single column, that is column matrix X, Y, Z, and W. W would be the weight factor. Why unnecessarily we are introducing weight factor? When there is a need, at that time I will tell you what was the need for this particular weight. By making this 25, 10, 10, 25, 10, 20, and if the weight factor is 1, we can take the given system as it was, or else we can, if we are willing to keep the weight factor as 2, and we need to multiply with the system X, Y, Z. That is, instead 25 we can take it as 50, instead 10 we can convert it 20, instead 20 we can take as 40. If we are concerning about 0.5 as a weight factor, then we need to divide with 2. Therefore 25 becomes 12.5, and so on. And this is what we have, and I'll tell you what was the reason the W was taken, and the transformation is we are going to plan, we are going to accomplish by the 4x4 matrix. The 4x4 matrix should be H. This is what H, the transformation matrix, or let it be the translation transformation matrix. And what we are going to do, we are going to multiply with V. V might be the point vector which we are introduced here, and by doing the multiplication of this translation matrix with point vector, we will get the newer point of the end effector. This is what we are going to. Therefore, H is equal to translation of ABC. The translation of ABC, what we are going to do, we are going to write it as with I into the ABC. I we are make it as I in the 3x3, that is 1 0 0 0 1 0 0 0 1. This is the unit matrix or identity matrix, and we are going to make as ABC in the last column ABC, and the rest is 1. And this is the way, once we were started our problem, then it is very easy to understand. And please make a note of this particular problem. That's problem number 1. For the vector V is equal to 25i plus 10j plus 20k, perform a translation by a distance of 8 in x direction, 5 in y direction, and 0 in z direction. The transformation would be, we restart the formula, that is U is equal to H into V. H would be the translation matrix. The translation matrix is ABC. Instead of ABC, what we are going to do, the newer position, the newer distance which is taken in x direction is A, in y direction is B, and z direction is C. Instead A, we were introduced 8, 5, 0, and 1. This first 3 column remains same. We need change the ABC alone. And we have V, that is 25, 10, 20, and the weight factor is 1. And what we need to do, we need to multiply this 2 matrix. And there are peoples from other elective, that is you are already aware about the matrix multiplication. Since I am dealing with matrix, I will introduce how easy to do the matrix multiplication. You write the column of the second matrix into the top of this first matrix. You write the 25 at the top here, and 10, 20 and 1. Do the simple multiplication. That is 1 into 25 and 0 plus 0 into, just a minute.
Sir, how that one came?
Yes, tell me. Yes, tell me. This one, you are inquiring about this one.
Yes, sir.
Yes.
That one. Yes, sir.
Yes, weight factor. You are going to have the same input, then you keep it as 1.
Oh, fine.
Why we have introduced this one, I'll tell you. Because this is, we have the matrix is 4 cross 4. This is the matrix we have 4 cross 4. Then we need to have the in order to do the multiplication, we should have the same here the size of matrix should be m cross n, that is 4 cross 4. Here the size of matrix is 4 cross 1. In order to keep that 4, we are taking as weight at the end. Okay, even it has some points to add. I'll tell you a little later.
Thank you, sir.
Therefore, we have 33, that is 25 plus 8, 33, and then 10 plus 5, 15, then 20, 20. Here at the end we have 1. And this is what the translation by distance of this 8, 5 and 0. 33, 15 and 20. Okay, similarly what we need to do, we need to have a conscious about the rotation vectors. The rotation vector about each of the 3 axes by an angle theta can be written in this way, that is rotation of x in terms of theta. 1, you please make a note of the 3 matrix, that is rotation of x comma theta, rotation of y comma theta, and rotation of z comma theta. Yes, you please make a note of this matrix. 1 0 0 0 0 cos theta minus sin theta, etc. Similarly, you make a note of the rotation of y theta. Once it is over, tell me, I'll make a move of rotation of z comma theta. These derivation, if time permits, I'll tell you, I'll make a note of this derivations and all. Even in Groover also, Groover referred some article for this derivation. In Groover, we didn't find the derivation. Anyway, if time permits, I'll tell you the derivations. Derivation this particular matrix, that is rotation x comma theta, y comma theta, similarly z comma theta. He referred the textbook, MIT Press, Cambridge. The name of the textbook is Robot Manipulator, Mathematics, Programming and Control. The author is R.P. Paul. I think you please make a note of this rotation of z comma theta. Yes, we'll solve one more problem. Already it is time 12:20, and you please make a note of this problem number 2. It has only 2 steps, and rotate the vector v is equal to 5i plus 3j plus 2k by an angle of 90 degree about x-axis, and the rotation transformation, that is rotation transformation. There we concern about the translation transformation. These formula, that is H, when H concern the translation and theta concern rotational transformation. Here instead theta, we are going to introduce the 90 that was given 1 0 0 cos 90 minus sin 90 sin 90 cos 90 and 1, and we have the point vector as 5 3 8 1, and by doing the multiplication of this 2 matrix, we will get 5 minus 8 3 and 1. We need to write this at the top of this matrix, that is 5 3 8 and 1. 5 into 1 becomes 5, and 8 minus 8 here we have 3, and here we have 1. Therefore, we will get the rotation transformation as 5 minus 8 and 3. And this is what we are going to derive in the tomorrow's class. Do you have any doubts with these problems? Do you have any other queries?
No, sir.
Yes. Yes, Sabrina, are you ready to do the derivations?
Yes, I'll
Yes,
like put the picture tomorrow.
Yes, yes. If feasible, you upload today itself. I will make it. Will include with the presentation.
Yes, sir. I will.
Yes, Josana, are you ready to discuss about the NASA recent picture videos? And importantly, you need to have a concurrence information with that of Indian satellites, which is sent to as similar to that of NASA. Okay, are you ready?
Yes. About Mangalyaan or
Yes, 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 yes,
yes,
Mangalyaan.
sir.
Okay, do you have any other queries?
No, sir.
Okay, if you don't have any other